All right, so here we go. First thing is this. How much is each ticket that Roy spends? $100. Okay, you got it. So it's 100 for tickets. Okay. How much is each meal worth? 40 is correct. Okay. All right. So now you guys did this. So what's if you bought 6 tickets and 16 meals? How much did you spend? Okay, 1,200 and. All right. Does everybody agree it's 1240? All right, so we got 1240, agreed. All right, let's go to the next one. If he spends buys 8 tickets and 14 meals, how much did it cost him? 1360? Does everybody agree with 1360? Okay, very good, it's correct, it is 1360. All right, if he purchases 10 tickets and 12 meals, how much does he? 1480. 1480, okay, agreed, 1480. And then how about if he buys 4.5 tickets and 11 meals? 890? 600. Now say again, how much is it? 270. No, it's not 270, I know that for a fact. 890? Okay, so 890, everybody say 890? Okay, good, 890, I agree with that. Okay, 890, okay, good. All right, now, here comes the question now. All right, if he buys 6 tickets and 16 meals, is that going to be a feasible answer? Yes, because what's the most money he has? 1360, right? That's what we learned yesterday. Yes. If he has 1360 worth of tickets and meals, feasible answer. Yes, because he's got 1360 to spend. How about 1480? Feasible? No. No. All right, not enough money. Okay. How about 890 feasible? No, why not? Because you can't buy half a ticket. Exactly. That's not a feasible answer. Okay, all right, so now what's your rationale? The rationale on this is simple. 1240 is less than 1360, right? Okay, what's your rationale here? 1360 equals 1360. That's how much money he has. Okay, what's your rationale here? Oh, wait. 1480 is more than 1360. You can't do that. And then your rationale here is what you just said. Okay, can't buy, okay, half a ticket, right? Okay. Yeah, what do we say here? Can't buy. Put something like that in there. Can't buy half a ticket, okay? All right, so everybody good there so far? Stop this. 2a, all coordinates in the ordered pairs are integer values. Why is that true? All coordinates in the ordered pairs are integer values. Why is that true? That's right, because integers are whole numbers, these guys. We talked about this already. Because you can't have halves. Integers are not halves, right? Okay, so that's why, okay, that's true. It's true because, okay, you can't have, tickets, right, or meals. So they've got to be integers. Okay, let's go to B. If graphed in the coordinate plane, all the ordered pairs would fall either in the first quadrant or on the positive M axis. Okay, now why is that true? Why is that true? Yeah, right. Okay, so they can't be negative numbers. Exactly. So they're all positive, or in other words, they can't be negative numbers. So that's true. Okay, because you can't, have, negative, right? Meals or tickets, right? That's why it has to be the case. Very good. You guys are doing great. Okay, so that's what you write there. All right, now let's go to number 3 then. It says, write a linear inequality that represents all the ordered pairs Tm that are feasible options for Roy. Okay, so what would that linear inequality be? $100 times the number of tickets and $40 times the number of meals has to be less than or equal to how much? $1,360. Right, that's the equation right there. Okay. Okay, so on this one you got this, right? Here's this, and here's this, right? And here's this, right? All right, now let me ask you this. He buys 2 meals each day, and how many days is he there? 5. So how many meals would he buy? 10. So your job is to take 10 and substitute it for M. You got it, and then solve this equation. So go do that. You'll substitute 10 in for M and solve this equation. Okay, so when you solve this, it's t is less than or equal to 9.6, and therefore the answer is 9 tickets. Okay, you got it. There you go. Good job. So far, so good. All right. All right, on to the next part now. All right, now, here's the next part. Number 5. If Roy buys exactly 1 ticket each day, find the maximum number of meals that he can eat in the 5 days. And show your work, right? Okay, so here we go again. Okay, all right. So if he buys 1 ticket each day, how many tickets will he buy? 5, right, okay. So you can go like this, right? Put 5 in there, right? Okay. Okay, now your job, once again, just like last problem, now you solve for M, okay? Okay, so then M would have to be equal to 21 meals. That's right, good job, we got that. All right, now, here's your next task. Okay, so they're going to go and tell you to do this. To see what the feasible options are, you can use a visual display of the values of the graph. Okay, so here comes the thing. If you were to graph this now, right? And if you were to purchase 0 tickets, how many meals could you get? You guys do that. Do it on the calculator. 0 tickets, how many meals could you get? What you guys found out? 34, right. Okay, so you're going to put a point at 0, 34 meals on the axes. 0, 34 meals. If you were to buy 0 meals, how many tickets could you buy? 13.6. Now we're going to be a little 13.6 tickets, right? So you're going to go to the other axes and put a point at 13.6, right? Making sense? Now, take out your straight edge, whatever you got, and connect those 2 points together on a graph. Don't do that. Well, maybe that's wrong. You choose it.
No, you'll see it tomorrow. Trust me. Tomorrow's definitely Tuesday.